All right, good day, guys. Welcome to another class, still on chapter 1 on electrostatics. Remember, in our last class, we covered some things. We said that charge is an intrinsic property which matter is made of, and because of that, we know that matter is made up of atoms, and atoms are made up of electron, proton, and neutron, where proton and neutron are inside the nucleus. And the proton is positively charged, the neutron is zero charge, and the electron is negatively charged. So the positive charge of the proton and the negative charge of the electron, which made up the atom, make charge a what? A fundamental property of matter, right? And we also said that when a material, when an atom loses an electron, it become positively charged, and when it gains an electron, it become what? Negatively charged. And we said that the process of losing and gaining electron is called ionization, right? So we also said that the atomic number Z is equal to what? The number of proton and the number of neutron, right? And we also said that on the principle of charge conservation, that the algebraic sum of static charge in any closed system is equal to 0. That is the principle of charge conservation. The algebraic sum of charges, this I mean sum, right? So it's equal to what? It's equal to 0. Like in the human body right now, for a closed system, why you are not feeling the reaction of electric charge is that the sum, it's not that there are no charges. There are charges in every matter, but what happens is that these charges occur to balance themselves so that the resultant effect of those charges will be 0. For example, in a material we have what? 20 we have 20 proton. We have 20 proton. The number of electrons must balance. We know that electrons are negatively bound. The number of electrons must balance to be 20 so that the overall effect will be what? Equal to 0. All right. Now, if the number of electrons is not equal to the number of proton, that means that the material has been what? Ionized, and we said that before. All right, so in this presentation we are going to be talking about the principle of charge quantization. The principle of charge quantization. Now, what is the principle? You can write it down. Make sure you have a special book for this class. Any book you write it at all. Principle of charge quantization. All right. Now, what is the principle of charge quantization? Now, the principle of charge quantization states that in an isolated body, the total number of charges occur in whole number. You can write it down. It says the total number of charges in an isolated system occur in whole numbers. It's an integer multiple, right? What this means is that if I have a system here, let's say this is a system, the total number of charges in this system can be 5, can be 4, can be 6, right? So they can be 6, 4, 5. They are in whole numbers of the electron charge. So we have maybe, because we know that the electrons and the proton are the basic foundation of charges, right? So the total number of charges here are in integer multiple of what? The electron charge. So we cannot have something like 3.2 of electron charge. No. It's either 5 electron charge, 5e, 6e, 7e, They are in whole numbers. Are we getting it? So in this case now, let us try to derive something. Let us try to derive something before we go. Now, if we have 5e, 6e, 7e, we discover that what if we don't know the number and we represent the number by n, right? And we know that this E is constant because every material has electrons. So this will be E. So which means that the total number of charges is what? The integer number multiplied by the electron. So Q will be equal to Ne. So you can write that formula down. We'll be using it very soon. All right. So let us go to the next presentation, which is called quarks. It's called what? Quarks. Now, what are quarks? What are quarks? Quarks, let me write it down so that quarks. Quark is a postulate. Are you getting it? It's still a postulate. And the theory states that charged particles, are we getting it now? It said that the proton or those charged particles, these subatomic particles, are made up of smaller charged particles. Now, what is the principle of this quark? Quark states that the proton or the neutron that is chargeless and the proton that is positively charged, are made up of fractional units of electron. Now, in this quark, we have what we call the up quark. We have the up quark, and we have the down quark. Now, the up quark is represented by U, and the down quark is represented by D, right? So, okay. So, what is the value of one up quark? The value of one up quark. The value of an up quark U is equal to 2/3 of electron. And this 2/3 is positive because we name it up. Let us just understand it this way. You know, in your graph. That's not the secret, but I'm just giving an instance to understand. When you go up, we have positive Y, right? When you go down, you have negative. Okay, so we can just use that system to understand this. So up quarks have positive charge, and the value for up quark is 2/3 times E. Then down quark has negative charge, and the value for down quark is 1/3 of E. Right? Now, this postulate states that the proton is made up of 2 up quark and 1 down quark. It's something you should just understand, right? It says that the proton divided by P, the proton is made up of 2 up quarks, that is plus 2/3 E plus 2/3 E, because up quark is 2/3, right? And 1 down quark, is what? Minus 1/3 of what? E. Okay. down quark is minus 1 over 3 of E. So that is 1 over 3 E. So you say that the proton is made up of 2 up quark, and we know that up quark is 2 over 3 E. So this 2 up quark and 1 down quark. So when we solve this together, the LCM of everything is what? 3. And will be 2E plus 2E minus 1E. Right? So 2 plus 2 is 4. Minus 1 is what? 3. So that will be 3E over E. And 3 over 3 is equal to what? E. So which means that the value of a proton, I mean the charge on a proton, is equal to positive charge on an electron, right? So we have solved for that. Now, what of the neutron? According to this postulate, the neutron has 2 down quarks, and 1 up quark. And we know that down quark is 1 over 3E, right? So this is 2 down quark, and that quark have what? Minus sign. So that's minus 1 over 3E minus 1 over 3E plus, I'm getting it, 2 over 3E. Because down quark has what? Minus 1 over 3E, as we said just now. This is another down quark, it's 2 down quark plus 1 up quark, right? So if we solve this fraction, we have the LCM as 3, then this will be minus E plus 2E, right? So minus E is equal to what? Minus 2E plus 2E over what? 3. And minus 2E plus 2E is what? 0. And 0 over 3 is equal to what? 0. So which proves that the number of charge in a neutron is equal to 0. Right? So thank you very much for watching. We stop here. In the next class, we'll be taking a little problem in this part. Then we go to Coulomb's law. Thank you very much.